Welcome to Classes with Atish. Few days back we did a lesson on kinematics, and towards the end of the lesson I challenged you to solve one of the problems. It was from Irodov. So Irodov problem 1.10. I'll put up the problem somewhere on the screen, but this is the question. Let's try and solve it. So if two bodies were thrown simultaneously from the same point, one straight up and one at an angle of theta equals to 60 degree to the horizon. Okay. So one body was thrown straight up. So it will follow a path like this. At some point it will stop and then it will start to return back. Okay. The other body was thrown at an angle of 60 degree. So theta equals 60 degree. So obviously this will follow a projectile motion like this, and then it will try to, at some point it will fall down here. Okay. It says the initial velocity of each body is equals to v0. Alright. Neglecting the air drag, find the distance between the bodies t equals to 1.7 seconds later. So this is at t equals to 0. At t equals to 7 seconds later, maybe this is somewhere here, this is somewhere here. We don't know where it is, but our goal is to find out what's the distance between these 2 points. Okay. Let's look at body 1. The first body that is thrown vertically up. Okay. Its displacement, since it is thrown only in the y direction, it will only have a y component. So y1, we know s equals to ut plus half at square. So y1 will be u, initial velocity is v0. After time t, it will be v0t plus half at square. But now g is the acceleration in the downward direction. Okay, so minus half g t square. Okay, what about x1? X1 will still be 0. Body 2. Okay, what is y1? Y1 is, so the component of velocity vector for body 2 in the y direction. So if this is theta, then the component in the y direction is v0 sine theta. So v0 sine theta times t minus the same thing, half gt square. Okay. Sorry, this should have been y2. What about x2? Now x2, in the x direction, the component of v0 is v0 cos theta times t. And if do we have any acceleration in this direction? No. So this part is 0. Okay. Now, so the distance between the two bodies, or displacement distance between the two bodies, will be x2 minus x1 square plus y2 minus y1 square root of that. Okay. So x2 minus x1 is nothing but v0 square cos square theta t square, and what is y2 minus y1 whole square. So if we say y2 minus y1, these two components will cancel out, and this will be, let's write the full thing, v0 sine theta t minus v0 t whole square root of that. Let's expand this. Now this will be v0 square t square cos square theta plus, let's expand this, v0 square t square sin square theta minus 2 v0 square t square sin theta plus v0 square t square. Okay. Now v0 square t square sin square theta plus cos square theta is 1. Right? So this becomes v0 square t square plus we have another v0 square t square minus 2 v0 square t square sin theta. Now this is 2 v0 square t square, so v0 t, we can take it out, and this becomes root. So 2 if we take common, 1 minus sin theta. Or now let's substitute. So initial velocity v0 was 25 meter per second. After time 1.7 seconds, root 2 1 minus sine theta. Now sine 60 degree we know is root 3 by 2. So this becomes 25 times 1.7 square root of 2 minus root 3. Okay, let's do the quick math. 25. So this is roughly 22.1 meter. Okay, so that's the answer.